Now, moving on to the next part, that is the properties of some rational numbers. But before starting the properties of rational number, you need to be familiar with the properties related to whole numbers, properties related to integers, and the same can be applied to rational numbers also. So let us begin with the first property, that is the closure property of whole numbers. Now you are familiar what are whole numbers? A set or a collection of numbers starting from 0. That means all 0, 1, 2, 3, 4 and so on, they are called as whole numbers. Now closure property can be understood easily by the set of a bag. Like you can take a bag and imagine that all the whole numbers are there in that bag. And so if I took any two whole numbers out of the bag and I add them together, so what will be the result of it? You'll find that the result is again a whole number. For example, if I take 2 and if I take 5, two different whole numbers, I add them together, 2 plus 5, the result is 7, which is also a whole number. So we can say here, in this case for addition, whenever we add any two whole numbers, the result will always be a whole number, right? For example, 1 plus 3 is 4, which is again a whole number. Sum of any two whole number is a whole number. Let us see, for 7 plus 0, the result is again 7, so which is also a whole number. Now see subtraction. If we subtract any two whole numbers, is the result always a whole number? You may take 5 and 4. So if you do 5 minus 4, you'll get the result as 1, and 1 is a whole number. But what if you do 4 minus 5? Is it possible that you can subtract 5 from 4? That is 4 minus 5. The result will be negative 1, and negative 1 is not a whole number, rather it is an integer. So we can say here the difference between any two whole number is not always a whole number, it may be different also. As in the example we have seen, it was an integer. For example, 4 minus 3, that is 1, is a whole number, but 7 minus 4 is again 7, which is a whole number. Also, if I take 6 minus 7, I get negative 1, which is not a whole number. So it is not necessary that every time we get a whole number. So we say the whole numbers are not closed under subtraction. See, in that bag of whole numbers, you will not get the number minus 1 because it is not there in the bag, it is actually an integer. So you can easily say that the bag is not closed for subtraction. Similarly, you can try with multiplication and division also. So for multiplication of two whole number, we say that it is always a whole number. You can take with several examples here. Similarly, for division also, if I say, is it possible? Of course not. When we divide any two whole number, the result is not a whole number always. For example, 1 divided by 4, I'll get 1 upon 4, which is a fraction and not a whole number. So the division is also not closed. The whole numbers are not closed under division, and whole numbers are closed under multiplication. So we come to a conclusion here that whole numbers are closed for addition and for multiplication, but not for division and subtraction. Now let us see the closure property for integers. In the same way, you can apply it to integers also. When you add two integers, you get the result is always an integer. For example, if you'd add minus 4 and 3 is minus 1, result is always an integer. All this you have already done in your junior classes. It's just a recall of them. So let's move ahead with subtraction. As in case of a whole number, it's the same in the case of integer also, but here the difference between any two integer is always an integer, whereas for the whole number it was not the same. In that case the result is not always a whole number. So here for an integer we can say that yes, subtraction is closed for integers but not for whole numbers. So let us take an example here. I say 4 minus 3 is 1, which is an integer, and also if I do 6 minus 7, the result is minus 1, which is also an integer. So we can say yes, this property of subtraction, the closure property under subtraction, is true for integers. Next, let us move on to the multiplication. The multiplication of two integers here, it is always an integer. You can try again with any two integers and you'll find that the result is also an integer, as you can see here. And remember, 0 is also an integer. Now for division, if I take, then when we divide any two integers, it is not necessary that we get an integer always. So division is not closed for integers also, as it was not closed for whole numbers. Like -1 divided by 4 is -1 upon 4, which is also not an integer, it is a rational number. Now directly we can move on to the property of rational number. Now here the main thing starts. The previous one we have already read in our grade 6 and grade 7. Now let's begin with the rational number basically, but we can relate it to the closure property of addition for whole numbers and for integers. Now sum of any two rational numbers will also be a rational number. For example, if we add 1 by 3 and 4 by 3, you know the denominators are same, so we can simply add the numerators, that is 1 plus 4, and you get 5 upon 3, which is also a rational number. Similarly, if I add like this, you'll get 7 by 12 and -2 by 3. The two are different rational numbers. So the LCM of 3 and 12 is 12 here, and finally we get here 7 plus -8, which further gives 7 minus 8, and the result is -1 upon 12. And -1 upon 12 is a rational number. So we can say when we add two rational numbers, the result is always a rational number. Always remember how to add two rational number. Don't forget to take their LCM and then find the value. You have to take LCM in case if it is added or in case if it is subtracted, but not in case if they are multiplied or divided. Now let's see about subtraction. Is the same property applicable for subtraction also or not? Difference of two rational numbers is also a rational number. So you can take an example over here. With any two examples, you can find out the result will always be a rational number if they both are positive, or if one is negative, one is positive. With any example, you can give a trial, and yes, you'll find that 3 upon 4 is also a rational number. So we can conclude that the difference of rational number is always a rational number. Let's see about multiplication now.